All right, let's talk about one of the most fundamental and powerful tools in React, the useState hook. Seriously, if you've ever wanted to make your components interactive, to make them remember things, useState is where it all starts. So let's dive right in and really demystify how this thing works. But before we even touch React, let's back up a second. Let's think about a plain old JavaScript function. It runs, it does its thing, and then poof, all its variables just disappear into thin air. So how in the world, when we're building UIs with components that are basically just functions, how do they remember anything? Like, how does it remember a user's input or how many times a button has been clicked? Yeah, the short answer is they don't. Not by themselves anyway. A regular JavaScript function has no memory of past executions. It's completely stateless, and that's the exact problem that React is designed to solve for us. It gives our components this special kind of memory, and we tap into that memory using something we call state. So here's our game plan. We're going to start with what state actually is. Then we'll break down the useState hook itself. After that, we'll tackle the tricky parts, the update queue, and this idea of state as a snapshot. We'll also cover how to handle objects and arrays, and we'll wrap it all up with some common mistakes that, after this, you'll know exactly how to avoid. Let's do it. Okay, so what is state, really? The absolute simplest way to think about it is just this. It's a component's private memory. It's any piece of information that component needs to hold on to between renders. Data that's probably going to change over time because a user is interacting with your page. And to manage this memory, React gives us these special functions called hooks. useState is the most essential one of them all. It literally lets you hook into React's state management system. It allows you to declare a special state variable, and this is the magic part. It tells React to automatically re-render your component anytime that variable changes. All right, let's get into the nitty-gritty. How do you actually use it? Now, the syntax might look a little bit strange if you haven't seen it a lot, but trust me, it's incredibly clever and powerful once you get the hang of it. This one line of code is doing a whole lot. First, we're calling the useState function, and we're giving it an initial value, in this case, 42. And what it gives back is an array with 2 items. We're using this cool JavaScript feature called array destructuring to pull those 2 items out into their own variables. The convention is always something and set something. So what are these 2 things we get back? Well, the first one, age, that's our actual state variable. It holds a current value. The very first time our component renders, it's going to be 42. The second one, setAge, is the updater function. And this is key. You never change the state variable directly. Instead, you call this function to tell React, hey, I need you to update this value. And React takes care of scheduling a re-render for you. Okay, this brings us to one of the biggest gotchas in all of React, especially for newcomers. It all has to do with how, and more importantly, when your state updates actually get applied. Seriously, getting this next part will save you hours and hours of frustrating debugging. So picture this. You've got a button, and inside its click handler, you call your setter function 3 times, back to back to back, just like you see here. Your goal is pretty simple, right? You just want to add 3 to the age with one single click. So if our age starts out at 42, what do you think it's going to be after that click? I mean, it's got to be 45, right? We added 1 3 times. It seems obvious. But it's not. The answer is actually 43. It only goes up by 1. And the wildest part is, this isn't a bug. This is React working exactly as it was designed. So what on earth is going on here? The reason this happens is because of the single most important concept for understanding useState. You have to think of state as a snapshot. This is the big aha moment. So here's the deal. When your click handler starts running, the value of the age variable is fixed. It's a snapshot of the state at the moment of that render. For that entire function's execution, age is 42. It doesn't change. So when you call setAge, age plus 1 3 times, what you're really telling React is setAge 42 plus 1, then setAge 42 plus 1, then setAge 42 plus 1. You're just asking it to set the state to 43 3 different times. So how do we fix this? How do we tell React, hey, I don't care about the snapshot value. I need you to calculate the next state based on the previous one? Well, we do that with a functional update. Instead of passing the new value directly, you pass a little function. React will then call this function for you, and it will automatically pass in the latest pending state value as the argument. It's a total game changer. And this is what's happening behind the curtain. When you use those updater functions, React doesn't run them right away. It puts them in a line, a queue. Then, right before the next render, it processes that queue. It starts with the current state, 42. It runs the first function. 42 plus 1 gives you 43. Then it takes that result, 43, and runs the second function. 43 plus 1 is 44. And finally, it takes 44, runs the third function, and gets 45. And that final result is what shows up on the screen.
Let's move on to another absolutely critical concept: what to do when your state is an object or an array. There is one golden rule here, and I want you to burn it into your memory. Treat state as if it's immutable. That means you never, ever, ever change it directly.
On the left, we're mutating. We're directly changing a property on the original form object. The huge problem here is that when you call setForm, React does a very simple check. It sees the new object you gave it is the exact same object in memory as the old one, and it says, oh, nothing's changed, so it just bails and doesn't re-render. The right way is to always create a brand new object. We use the spread syntax to copy all the old properties, we overwrite the one we want to change, and then we pass that totally new object to our setter function. You always replace state. You don't modify it.
Okay, we've covered all the core theory. Let's wrap things up with a super practical troubleshooting guide for the most common errors you are definitely going to run into. Here are the big three. First, you log your state right after setting it, but you see the old value. What's going on? Remember, state is a snapshot. The new value won't be available until the next render. Second, your screen just won't update when you change an object or array. You almost certainly mutated it directly instead of replacing it. And third, the dreaded too many re-renders error. That means you're calling a set function right in the body of your component, which causes an infinite loop. Always make sure you're calling setters from inside event handlers or use effect hooks. So, let's just quickly recap the most important takeaways. useState gives your components memory. State is always a snapshot for any given render. If your new state depends on the old state, you have to use an updater function. For objects and arrays, the mantra is replace, don't mutate. And finally, remember that React is smart and it batches your state updates to keep things running fast. Once you really get that state is a snapshot, that there's an update queue, and that immutability is key, you've leveled up. You're not just writing React code anymore. You're starting to think in React. So now that you really understand the why behind it all, what's the first thing you're going to go build? Thanks for watching.